Let's go through question 3 of the November 2022 physical science exam. Now it says a ball is thrown vertically upward from the top of a building at height 25 meters with a velocity of 12 meters per second. On its way down, the ball passes a door which has a height of 1.9 meters and then strikes the ground, as shown in the diagram below. Ignore the effects of friction. Let's begin with what we know. We know that at the top of the building, which is 25 meters from the ground, our ball has a speed of 12 meters per second and is going upward. Now let's draw up the motion of the ball. It's gonna leave this point here, it's gonna go up, reach the highest point, and then come back down, passes the original height, and then goes back down until it hits the floor. Now let's note all the critical moments during its motion. The first, we'll say A, is when it leaves the top of the building, and it leaves at 12 meters per second going upwards. It reaches the highest moment. Let's call that point B. Now at that highest moment, it changes direction and comes back down, passes its original height of departure. Let's call that point C. And while it's traveling down, it passes a door of 1.9 meter height. Now let's A, B, C, D. Let's mark the top of that door 2 as a critical point, and then our last critical point will be the ground, and we'll mark that point E. Now at each critical point, what information do we have? Let's start with at A. At A, its initial velocity, we know that it is 12 meters per second going up. At this moment, I can decide that, okay, my up will be my positive. For the rest of this entire question 3, I will always take up as positive. So the ball will move from A, moving upwards at 12 meters per second. We know the initial velocity, which is equal to 12 meters per second. Do we know the initial elevation? Let's say yi. So the initial position is 0 meters because I will take the point at which it was launched as my reference point for the rest of the question. Now the third thing that we need to know is to know the initial time. So the beginning of the motion will have our t0, so our time there will be 0 seconds because that's where we start to observe our motion. That's for point A. Now it goes up until it reaches point B, which is the highest point on our projectile motion. Now what do we know at point B? Do we know the velocity at B? We do know, because you know that when you throw a ball straight upwards and it reaches the highest point and changes direction, it must stop moving first and then start accelerating downwards. So the velocity at the highest point is 0 meters per second. Do we know the elevation? If we take A as our reference point, we currently do not know how high it went until it reached the highest point on its projectile motion. Now, do we know how long it took to get to B? We also do not know. It is not given in our problem. Now, point C. At point C, do we know our velocity? Yes, we do. Because if we ignore the effects of air friction, the velocity it launched to go up to point B is the same velocity it will be when it comes back at C. It will just be in the opposite direction. So if here at the same height it went up at 12 meters per second, when it comes back to the same height, it will now be equal to negative 25 meters per second, because we are dealing with velocity here. Velocity is a vector, so it has direction. So we know that it is going now moving downwards. And we said that up is our positive. Now, do we know the elevation here? If, again, A is our reference point, it is the same height, C is the same height as A. So our elevation here will again be 0 because it is the same height as our reference point. Now, do we know how long it took to get to go up and then come back to C? We do not know. Now, what about at D? Do we know the velocity at D? Now there's no reference that we can make, so we cannot assume the velocity at D. So we don't know the velocity at D. Do we know the elevation though? Now the elevation at D, it is 25 meters minus 1.9. Now if we take A as our reference point, that means point D will be 25 minus 1.9, which is 23.1 meters. But it is negative because it is below our reference point. And we say that up is positive. So all the points that are above our reference point will be positive, but the ones that are below will be negative. Do we know the time it took to get to D? We also do not know that. If we took our ground as the reference point, then D would the elevation at D would be 1.9. But now we are taking it from here, so we want the distance from here to here, 25 minus 1.9. Now let's get to the ground, which is point E. Do we know the velocity at point E? We cannot make any reasonable assumption, so we do not know the velocity at E. But do we know the elevation? Elevation at E. Now again, if our ground was our reference point, the elevation would be 0. But since A is our reference point, that means E is all the way at 25 meters below A. And because it is below A, it will be negative 25 meters. 25 meters. We cannot also assume how long it took to get to point E. So we do not know T at E. Question 3.1 says, define the term free fall. Now, free fall, it's motion. It's motion where the only force acting on the moving object is gravity. Now, when something is in free fall, is when the only force that is acting on that object is gravity. An example of that is when you throw a ball in the air. No other force is acting on that ball, ignoring air friction, except gravity. Now, when you throw it up, gravity will try to pull it down, so it will go up and slow down and then come back down again because gravity is pulling it down. So that is what free fall means. Another example is if you jump off a building. Now, if you jump off a building, the only force that is acting on you is the force that is pulling you downwards to the ground. And we say that you are in free fall. 3.2 says calculate the following. Time taken for the ball to reach its maximum height. So we want the time it takes to go from point A to point B, because our point B, it is the maximum height. To do that, we are going to go to the equations of motion. Now, to use the equations of motion, the best thing you can do is look at the equations and then look at the givens that you have between the 2 points that are in question. Now, since we are going from A to B, we'll see what we have between A and B that we can use in our equations of motion. The first equation says Vf equal to Vi plus A delta t. So do we have the final velocity at B? Because A will be our initial, it moves to B, and B will be our final. Do we have the final velocity? We do, because we know that at the maximum height, our ball will be stationary. When you throw a tennis into the air, at its highest point, it will stop going up, and then we say the velocity is 0 there, and then it will start coming back down again. The same thing happens to this ball. So we do know that Vf is 0 meters per second. Now, do we know the initial velocity, meaning the velocity at A that it launched at? We do know that it is 12 meters per second. It was given in our question. Now, A, acceleration. Do we know the acceleration of the ball? Yes, we do, because since this is vertical projectile motion, we know that that ball has gravity acting on it. It is in the y-axis, therefore gravity is acting on it. So our A here will be, will substitute G in space of A and take the gravitational acceleration, because our ball is in free fall and the only force that is acting on it is gravity. Therefore, we use gravitational acceleration, which is equal to 9.8 meters per second squared. Now, do we know delta t? The question says calculate the time, so that's what we are looking for. So I don't need to check the other equations of motion. I'm satisfied that this first equation will get me what I want. Now let's write it down. We have Vf equal to Vi plus G delta t. Now it's G here because remember I substituted the gravitational acceleration in space of A. Now let's substitute in our equation. Vf, we said that it is 0 meters per second, equal to Vi, which is our initial velocity, will be equal to 12 meters per second. Now it's positive 12 because initially it is moving upwards, and we say that up is positive. So we'll substitute a positive 12 at the initial velocity, plus G. G is 9.8. But we said up is positive, and you know that gravitation acts downwards. So our acceleration here will be negative. Now for delta t, that is what we are calculating. And then all we have to do now is solve for t, which will be 12 over 9.8. And you'll get that it is 1.22 seconds. So that means that our ball, it took our ball 1.22 seconds to go from A all the way to its maximum height. 3.2.2 says calculate the velocity in which the ball strikes the ground. So we want the velocity at E. How fast will the ball be when it reaches the ground? The thing you have to notice here is that wherever this ball is coming from, that will be our initial position, and E, where it finally ends up, will be our final position. Now let's look at the equations of motion again and see what we have. Now we are looking for speed. It wants the velocity, so we want to calculate the speed at which it reaches point E. We know that the direction is down, hence velocity. Now we are going to look at our equations of motions and look at the ones that have velocity. Now as I look at them, all of them have velocity, so I can use any one of them. Now the second thing I'm going to do is to look at my given at point E and wherever initial point I take. Now let's say that my initial point is point A. Taking A as our initial and E as our final, let's look at our equations of motion. The first equation says Vf. Do we know the final velocity? That's what we are looking for, the velocity when it hits E. Now Vi, which is the initial velocity, we do know it was 12 meters per second. We do know the acceleration, which will be the gravitational acceleration. Do we know the time it took to go from A to E? We don't. Therefore, we cannot use the first equation of motion. Now, let's look at the second equation of motion. We are looking for Vf, so that's fine. Now, do we have the rest of the equation? We have Vi, we have acceleration, and we have the height. Now, we are going to use this delta y because the motion is in the y-axis. It is vertical motion. Now, what is that height between A and B? We know that the height is 25 meters per second. So we have the height, the acceleration, the initial. Therefore, we can calculate the final velocity. Our equation is Vf squared equal to Vi squared plus 2g delta y. Remember, I'm substituting A for G because the only force acting on the ball is gravitation. Therefore, I'm taking gravitational acceleration. Now, I substitute into my equation of motion. What is the initial velocity? I know that it went up 12 meters per second plus 2 into my gravitational acceleration is 9.8 meters per second squared. It is negative because gravitation acts downwards, and we said that up is positive. Now, what is my height? My height is 25 meters, but it is below my reference point, my initial point. Therefore, it will be negative. If it was somewhere higher, then I would have taken it as positive because I said up is positive, but now it's below, it becomes negative. Now I can calculate my Vf, which is equal to 25.18 meters per second. It makes sense that it is so high because it is accelerating at 9.8 meters per second. So as it goes down, because of gravitation, it will become faster and faster and fast. So it makes sense that it is higher than the initial point. Now, since we are calculating velocity and not speed, we need to show our direction. Since at the ground, it hits the ground while going downwards, our direction will be downwards. We are not just calculating speed, we are calculating velocity. Speed is a scalar and velocity is a vector. So velocity needs magnitude and direction. 3.2.3, it says that calculate time it took the ball to move from the top of the door to the ground. Between these 2 points, do we know a lot of information? Now, we now know the final velocity, which is 25 meters per second. Do we know the elevation between the 2 points? We know that it's 1.9. Now, do we know the time it took? That's what we are being asked to calculate. So we go back to our equations of motion, and then we look at each one of them to see which one is best fit for our problem. Now, we want the one that has time because they're saying calculate time. So it's going to be number 1, number 2, and number 3. And this one will not work because it does not have time. But the first equation, do we know the final velocity? We know that at E, it is 25 meters per second. Do we know the initial velocity? Now, the initial velocity, it's now at D because we want to find out how long it took from D to E. We do not know how fast it was going when it reached the top of the door. So we do not know initial equation, which means now we don't know Vi, we don't know delta T. That's already 2 unknowns in one equation, so that equation will not work. Now we go to our second equation. Now, do we know delta y, which is the elevation? Yes, we do. It is 1.9 meters. Do we know initial velocity? We do not know the velocity at d. So this equation that already does not work. We see that vi will be a problem because we do not know the initial velocity at d. Because of that, let's find that initial velocity because it seems to be very important. If we are going to use any of these equations, our initial velocity is important. How can we find that? We can use our original reference point and then calculate the velocity at d because we have a lot of knowns at a, and then we can look at d. Now, I can cancel off a lot of equations here because I don't know the time it took to go from A to D. So equations that have time will not work for me. So I have to use this equation right here. It is the only one that has time. And since I don't know how long it took from A to B to D, I cannot use any of those. So I will take Vf squared equal to Vi squared plus 2g delta y. Now let's substitute. Now, because we are now taking A as our reference point, A will be our initial point and D as final. So we are calculating V final, which will be our initial when we calculate the time it takes from D to E. So do we know our initial velocity? Yes, it is 12 meters per second plus 2 into negative 9.8. Do we know the delta? Now the delta y is the distance between A and D. We do know that it is negative 23.1 because it is the difference between A and the top of the door. So 25 minus 1.9. And we find out that our velocity at D will be equal to 24.43 meters per second. Now it makes sense that at D it was slower than at E because it's still accelerating downwards. Remember, velocity is going downwards. Now that we have the velocity at D, we basically now know the VI in all of these equations. So I can use this one where I know the final and the initial and I'm looking for delta T. I can use this one and I can use this one. Let's use the first one. I like the first one because it is the simplest. So Vf equal to Vi plus G delta T. Our final velocity will be minus 25.18 equal to our initial will be minus 24.43. They are moving downwards, therefore they are negative, plus negative 9.8. Then we are looking for delta T. So your delta T will be 0.08 seconds. Now we have found our time and we now know the time it took for the ball to move from the top of the door to the ground. Now 3.3 says draw a velocity versus time graph for the motion of the ball from the moment that the ball is thrown upwards until it strikes the ground. Use the ground as zero reference. Clearly indicate the following on your graph: the velocity with which the ball was thrown upwards, time taken by the ball to reach its maximum height, the velocity with which the ball strikes the ground. I draw my axis. I know that the x-axis will be time in seconds and my y-axis will be velocity in meters per second. We said that we take up as positive. So everything that is moving upwards will be positive above the x-axis. If it's negative, it will be below the x-axis. Now let's start with our initial velocity. At A, do we know the velocity? Yes, it was 12 meters per second and it was moving upwards, so it was positive. So we'll put a positive 12 here, all in meters per second. Now, at its highest point, that's when the velocity is equal to 0. So it will cut the x-axis, the axis of time, because our velocity there is 0. So it will move straightwards like this. It goes from being 12, reduces at 9 meters per second squared until it reaches 0. Now after that, it starts to move downwards, and because now it's moving downwards, when we set up is positive, everything now will be below the x-axis. Now it will keep going and going and going and going. We'll have some critical points on our velocity versus time graph, which is, we know our initial is 12 meters per second, at the maximum height is 0 meters per second, and we calculated that it took 1.22 seconds to reach there. So we can write that down and say here we have 1.22 seconds. Now they also want us to show the velocity in which the ball strikes the ground. Now when it hits the ground, we calculated that it hits the ground at 25.18. But remember, it hit that 25.18 moving downwards. So that 25.18 becomes negative. It is below the x-axis. So it will be somewhere there.